Hello, in this video we are going to cover section 1.1, solving linear equations of one variable. An equation of one variable x is a conditional statement expressing that two algebraic expressions are equal, which will be true for certain values of x and false for others. All right, so when you have an equal sign, that kind of a statement will either be true or false. But when there's variables involved, you can't determine whether it's true or false until a number is plugged in for that variable. So once we choose a value for x, like x equals 5, then we can decide whether the equation is true or false based on that choice for x. That's why these are called conditional statements, because they're true under certain conditions and false under other conditions. A solution to an equation of one variable is any value of x that makes an equation true. So any numbers that we could choose for x that result in the equation being true is called a solution. In general, solutions are conditions under which equations or inequalities are true. So going forward, as we look at more complicated types of equations, the concept of a solution doesn't change. It's whatever makes the equation or the inequality true. All right, so let's look at this example from the homework. Determine whether the given number is a solution of the given equation. So the number we're being given here is the number -6. Okay, sorry about that. I thought I was ready to write. Okay, here we go. -6. And the equation we're being given is 7x minus 4 equals -45. So this equation right now is neither true nor false because we can't determine whether it's true or false yet until we have a number plugged in for x. They're giving us a number to plug in for x. So they're asking us under the condition that x is equal to -6, will this equation be true or false? If it comes out true, we'll say yes, this is a solution, -6 is a solution. And if it comes out false, we'll say no, -6 is not a solution. So what we're going to do is take this number here, and they don't put x equals here, but this is what they want x to equal. And we're going to plug that in for x into the equation. All right. So we have 7x minus 4 equals -45. That's the equation. In place of x, we are going to plug in the number -6. Everything else about the equation is going to stay the same. On the left-hand side, we're going to simplify. So 7, we'll start with order of operation, which is multiplication. You know, PEMDAS is the order of operation, but in this case, we jump right to the multiplication. 7 times -6 is -42. Minus 4 equals -45. And then we do the subtraction, and we find on the left-hand side we get -46. On the right-hand side we have -45. And whenever you're dealing with the equal sign, that is only ever true if the left-hand side has the same value as the right-hand side, which it doesn't in this case, right? -6 is not the same value, sorry, I said the wrong number. -46 is not the same value as -45, and so this is false. This is a false statement. So under the condition that x is equal to -6, this equation is false, which means -6 is not a solution. All right, so on our homework, we will mark the answer of no. All right, oops, kind of missed the mark there. All right, let's look at the next slide. Determine if the given number of a solution, sorry, I'm reading it wrong. Determine if the given number is a solution of the given equation. So again, this time we're given the number 40, kind of a big number, and we want to know if that's a solution to this equation. 8x, sorry, wrong letter, 8z plus 15 equals 335. So this time they're using a different letter as the variable, but it works in the same way. We're going to plug this number in for this variable here. So in place of z, we're going to plug in the number 40. Everything else around the equation is going to stay the same, so we'll still have the 8 that's in front of it, times this number for z, plus the 15 equals the 335. All right, so same as the previous exercise, we will do order of operation, PEMDAS. Multiplication is going to come first. So this will be 320. Right? Not that I'm great at doing numbers in my head, but 8 times 4, I do know that one, that's 32. And then the extra 0 just gets tacked on to that. Plus 15 equals 335. And then we'll add these two numbers together. We get 335 equals 335. All right, so in this case, the value on the left-hand side is exactly the same as the value on the right-hand side. So this time it came out true. So under the condition that z is equal to 40, this equation will be true, which means that 40 is a solution to this equation. So that's the label we give that. So this time we'll mark yes on our homework. All right. To solve a linear equation of one variable, we will isolate that variable on one side of the equation. So assuming the variable is x, we isolate x on one side of the equation. This can be accomplished using a couple of principles of equations. You can add or subtract the same thing to both sides of an equation. This principle has an official name called the additive property of equations or something like that, but it's how everybody regards it is you can add or subtract the same thing to both sides of an equation. And there's also a multiplicative property for equations, which allows you to multiply or divide the same thing to both sides of an equation. So we're going to use this to our advantage to manipulate the equation into telling us what the solution is. Because what we don't want to do is go through this algebra class having to guess at what the solutions are for the equations that we're given. Guessing is a bad way of trying to solve equations. That's what we did on these previous two, right? So in this example right here, we guessed -6 as a solution to this equation, and it didn't work out. It was not a solution. So if we're trying to find the solutions to this equation, -6 wasn't one of them, we'd have to pick a different number, plug it in, see if it comes out true or false. If that one didn't work out, we'd have to try a different number. And there's no telling how long it would take us to actually find the solution to this equation. And even when you find one that works, how do you know that's the only solution? Maybe there's two solutions. You have to keep looking, right? And so you'd have to make an infinite number of guesses to find all the solutions to this equation, which is not the way we want to be doing these problems. So instead of picking a number, plugging it in and hoping it works, the best method is to manipulate the equation using these two properties into telling us what the solution is. And then we'll have the answer, right? So let's practice doing that on a few of these problems. So here we have -21 equals x minus 10. We want to solve this equation using the addition principle. So that principle tells me I can add or subtract the same thing to both sides of the equation without changing the solution. And so I could add whatever I want. So just as a point of principle, I could add 5 to both sides. Right? Add 5 to the right-hand side, add 5 to the left-hand side. Right? There's nothing wrong with doing that. That's mathematically acceptable, but it doesn't get us any closer to figuring out the answer. Right? The equation becomes -16, right? Because -21 plus 5 is -16, equals x minus 5. Right? So we get a new looking equation which should have the same solution as the original equation. So the way I like to say that is, if -21 equals x minus 10, then it would also be true that -16 would equal x minus 5. Right? These two equations would be true. If one's true, the other one's automatically true. But we're no closer to having the answer that we're looking for. So instead of adding 5 to both sides, let's start over again. We have -21 equals x minus 10. Let's add 10 to both sides. Now what that does is it gets rid of the number from the right-hand side. To balance that out, we have to add the same number to the left-hand side. So we get -10 plus 10. Those cancel each other out, leaving us with just x by itself on the right-hand side. That is isolating x. By having x isolated, the equation is going to tell me x is equal to this number. That number will be my solution. So we get -21 plus 10, which gives me -11. And so now the equation is telling me what the answer is. I don't have to guess at it. The equation's telling me x has to equal -11. If -21 equals x minus 10, then it's also true that -11 is equal to x. And that's the answer we're looking for. That's the value of x that makes the equation true. And this also tells me it's the only one. I don't have to go look for other solutions. The equation's telling me there's only one number that works, and it's -11. And so that would be our solution. That's what we would type in as our answer into the homework. All right, let's take a look at another example. We have negative 14. Let's write it over here. Negative 14z equals 84. This time, to isolate z, we are not going to add 14 to both sides. Right? If I add 14 here, and I add 14 to the right-hand side, again, that's mathematically acceptable to do, but it doesn't accomplish the thing you're hoping it'll accomplish. This plus 14 does not cancel out this negative 14 because this is being multiplied to the z. If we want to cancel out a multiplication, we have to use division, right? Not addition, so that's not going to work. What we want to do is divide by negative 14 on both sides. So whatever number you're multiplying by, to cancel it out, you divide by that same exact number. If it's negative, you divide by a negative as well, right? So multiplying by negative 14 is canceled out by dividing by negative 14. So these are going to cancel each other out, leaving me with just the z by itself. And then on the right-hand side, I get positive divided by a negative, which will be negative. And then 84 divided by 14. So I don't know this one off the top of my head. I'm going to say, I think it's 6. All right, so I think I'm going to put negative 6 here. You might want to double check me on that with your calculator, but I'm pretty sure that's right. All right, so we get z is equal to negative 6. Again, manipulating the equation into telling us what the answer is. All right, let's take a look at another example. This time it's going to get a little bit more complex. So this time we'll have multiple steps we have to take to isolate the x on one side of the equation. So the first step here to get x by itself is we got two things to get rid of. We got to get rid of the 5, we got to get rid of the negative 13. Now if you think of order of operation, you might think, well, I want to deal with the multiplication first before I deal with the adding or subtracting. But when you're trying to isolate a variable, you actually want to do the order of operation in reverse order because you're trying to undo everything. You start with the last thing that would happen and undo that one first. So we actually want to undo the adding or subtracting. That's the easier way to go. You actually don't have to do it that way. You could divide by 5 first, but it's going to be a mess and it's not going to be easy to work through. The easy path is to do the adding or subtracting first and then do the multiplying or dividing second. And so to get x by itself, the first thing I'll do is cancel out the minus 13 by adding 13 to both sides. So I apologize for that. So there's a button on my pen that I use that when you press it, it erases. And I try to avoid pressing it, but it's really kind of hard to do. All right, so we'll add 13 to both sides. The minus 13 cancels out with the plus 13. That leaves me with 5x on the left-hand side. The 13s are gone. On the right-hand side, we had to also add 13 to keep the equation balanced out. And we'll get 32 plus 13, which is going to be 45. All right. So that's the first step. Get rid of the minus 13 by doing the opposite, which is adding 13. And then we will get rid of the multiplying by 5 by dividing by 5 on both sides. So we'll divide by 5 on both sides. The 5's here are going to cancel out. We'll get x by itself. X is equal to 45 divided by 5, which is 9. All right, and that would be the solution for this one. So this time we had to go through 2 steps to isolate the x on one side of the equation. And there's going to be some that are going to get a little bit more difficult. So let's see what we're going to have next here. So, i.e. Fractions, right? That makes things more difficult. Now, dealing with these fractions could slow you down quite a bit. To add these two together, these are like terms. This one has an x, this one has an x. So we could just add these together, but the fractions slow us down a little bit because they don't have a common denominator. If you want to add fractions together, you have to have a common denominator. And that's going to take a little bit of work. And then even after we figure that out, we'll still have a fraction to deal with to get x by itself, and that's going to be kind of a mess also. And so my advice on these equations, when you have multiple fractions, now if you only have one fraction, maybe you just deal with it. But if you have more than one fraction, let's just get rid of the fractions. It's actually pretty easy to do. You might be surprised. What you have to look for is a common denominator to all of your fractions on both sides of the equation. So we have to look at all 3 of these. We have 5 as a denominator, we have 10 as a denominator, and we also have another 10 as a denominator. So the common denominator, which is often abbreviated LCD, least common denominator, in this case would be 10, right? 10 is the smallest number that can be divided by all these. That's how I think of common denominator. What's the smallest number that can be divided by 5 and also be divided by 10? And the answer is 10. And so we multiply whatever common denominator you come up with. See if I can circle this here. You multiply it to both sides of your equation. So again, we're allowed to do this, right? It's the multiplication principle. You can multiply the same thing to both sides. I'm going to multiply a 10 to the left-hand side, and I'm going to multiply a 10 to the right-hand side. So let's do the right-hand side first because it looks a little bit easier to do. We have 10 being multiplied to this fraction. So think of the 10 as a fraction. Think of this as 10 over 1. The 10 here is on top in the numerator. This 10 is on the bottom. They actually are just going to cancel each other out. We'll have 10 divided by 10. They just cancel each other out. And so what happens when you cancel a number out from a fraction is it leaves a 1 behind. And then you multiply these fractions together. Now to multiply fractions, you do not have to have a common denominator. You just multiply. You multiply straight across like this. So I'll have 36 times 1, which is going to be 36 on the top. On the bottom, I'm going to have 1 times 1 because that's all that was left over there, which will be 1. And then 36 divided by 1 doesn't have to be written as a fraction anymore. That's just going to be the number 36. Sorry, excuse me. Just kind of getting over a cold, so my voice isn't quite back to normal. Get a little bit of a drink there. All right. So we'll do the same thing on the right-hand side. Or sorry, got my directions backwards. We just did the right-hand side. We'll do the same thing on the left-hand side. But we have to do it to both of these. So this 10 is going to get distributed. Because when you multiply something to the left-hand side of the equation, it multiplies to everything over there. So 10 will get multiplied to both of these fractions. Because they're fractions, it'll be helpful for me to think of this as 10 over 1. And I'm going to do my scratch work over here, and then we'll write the result back over on the left-hand side of the screen. So we're going to have 10 over 1 times 7 over 5. Now when you practice this a few times, you'll be able to kind of work this out in your head. What's going to ultimately end up happening is that the 5 on the bottom should cancel out with my common denominator of 10. Right? If these don't cancel out, then you don't have the right common denominator. The 5 goes away, it divides into the 10, which leaves me with a 2. Right? I'm dividing a 5 out of both of these. If I divide 5 by 5, I have a 1 left over. 10 divided by 5 leaves me with a 2 left over. So essentially what's happening is this number will get divided by 5, so 10 divided by 5, which gives me 2. And then multiplied by the numerator. So you divide by the denominator, multiply by the numerator, and that's how you get the result. 10 divided by 5 gives me 2. 2 times 7 is going to give me 14. All right, and so this will become 14 right here. So this part here becomes 14, and then the x just gets copied down. Right. Plus, we'll do the same thing here. 10 divided by 10 gives me 1. 1 times 4 is going to give me 4. So again, divide by the bottom number, multiply by the top number. 10 divided by 10 is 1, times 4 gives me 4, and then the x gets copied down. In case that was a little bit too much too fast, I'll go ahead and write this over here for you. So again, we have the fraction that was here to begin with, times the LCD, the common denominator. Think of it as being over 1. The 10s cancel each other out. We're dividing by 10 in both cases. So 10 divided by 10 here is 1. 10 divided by 10 here is 1. And then we multiply straight across. Right? We'll get 4 on top. We'll get 1 on the bottom. 4 times 1 is going to be 4. Right, so that's how we get that. All right, like I said, with a little bit of practice, you can do that pretty quickly. It's not as bad as it might look over here. Now that the fractions are out of the picture, this equation should be pretty easy to deal with. Now we still have these two terms here. Now in the last problem we had two terms, but only one of them had an x, so we had to add the other one to the other side. This one, they both have an x, so we should combine them together. They are like terms. We have 14 x's. We want to add to that 4 x's, so now altogether we have 18 x's. And that's still equal to 36. And to isolate that x, we want to get rid of the 18. We'll do that by dividing 18 on both sides, and we'll get x is equal to 2. And there's our solution. So that is how you will deal with fractions in your equation. You'll just get rid of them. Find the common denominator, multiply it to both sides, fractions go away. All right. So here we get an equation that's a little bit more complex because now we have x on both sides of the equation, and that makes things a little bit more challenging. To isolate x means x can only be on one side of the equation. We can't have x on both sides. So when I look at this equation, the first thing I want to deal with is not having x on both sides of the equation. I don't want to see that. So I'm going to get rid of x from one side of the equation. And in this case, I think it's going to be a little bit easier going if we get rid of x from the right-hand side. We have a positive 2x here, so to cancel it out, I will subtract the 2x from it. So we're subtracting 2x on the right-hand side. To balance that out, I have to subtract the same thing from the left-hand side. So I'm subtracting 2x from both sides. Let's see what we have left over. We have 8x minus 2x. Now, I do want to point out, when you're performing this operation, you are doing it to the entire left-hand side and the entire right-hand side. I'm not just subtracting 2x from this term, I'm subtracting it from the entire right-hand side. But because you're adding or subtracting, you have to combine like terms when you do that. And so it only affects the thing that it's like terms with. So the minus 15 doesn't get affected by this because 2x is not like terms with the 15. It's only like terms with the 2x. So that's why I write it just directly underneath the thing that it's going to affect. But I do want to point out I'm actually doing this operation to the entire left-hand side and the entire right-hand side. It only affects one term, however, when I do that. So same thing's going to happen here. So the 2x's here are going to cancel out, and we'll have, this is very important, a lot of students make a mistake here. There is a negative sign here, a minus sign here, which becomes a negative sign when that 2x goes away. So we get negative 15x on the right-hand side. On the left-hand side, we combine like terms. 8x minus 2x will give me 6x. The plus 39 was unaffected by this operation, so we're just going to copy it down. By taking this first step, we end up with a problem that is just like one that we've done before. Right? So it starts off a little bit different, but once we get rid of x from the right-hand side, it reduces itself down to a problem that we've seen previously. Right? Now it's just like this problem here. And to isolate x, we'll get rid of the number first by adding or subtracting, and then we'll do the division last. Right? So let's get back to this problem here. All right. And so, same as we did before, to get rid of the plus 39, to cancel out a plus 39, we will subtract 39 from both sides. All right, that's balanced out. The 39s are going to cancel out. On the right-hand side, we'll get, they're both negative, so the answer will still be negative, and we're just adding these together basically. So this will be 4, carry the 1 over, we get 54. Use a calculator if you need to use a calculator on that. The 6x was unaffected by that operation, so we just copy it down. And then to get x by itself, it's being multiplied by 6. So to get rid of that 6, we will divide by 6 on both sides. And we are going to end up with x by itself on the left-hand side because the 6's cancel out, so x is now isolated, it's by itself on one side of the equation, equals negative divided by a positive will be negative, and then 54 divided by 6 will be 9. Sorry about that. Okay, and that is the solution there. Let's take a look at another example here. Kind of the same kind of problem. So if you're watching this video, maybe you could pause the video for a moment and then try to see if you can figure this problem out for yourself, because it's a very similar setup to the problem we just did. And then resume the video and see if you come up with the same answer I'm about to get. I do want to caution you, if you're going to do this, that the answer I think this time is a fraction, so don't lose confidence if you get an answer that isn't so nice. That's why I put this one on here. It's really similar to the last problem, but the answer isn't as nice as the ones we've been getting. All right, so let's go ahead and take a look at this. Hopefully you've tried this problem yourself first before watching to see how I'm going to do it. There's a couple of paths that you can take, and I try to keep numbers positive as much as I can, especially in front of the variable. So you could subtract this a over to the left-hand side, but then you get negative 6a, and that's okay. Just be careful with the negative sign. But a negative sign is one extra obstacle that we can easily make a mistake with. So if you can avoid negative signs, that's one less mistake you might potentially make. So what I'm going to do instead is add the 5a over to the right-hand side to keep that positive. So I'm going to add 5a to the left-hand side to cancel out that minus 5a. I'm going to do the same thing to the right-hand side to balance everything out. I'm doing this because I can't solve for a while it's still on both sides of the equation. I got to get rid of it from one side of the equation, so I'm getting rid of it from the left-hand side. All right, and so we're going to be left with the 5a's cancel out here, so we'll have a positive 4 left over, equals a plus 5a, which is 6a. The minus 13 was unaffected by this operation, so we're just going to copy it down. And now we're back in the same boat that we were with the previous couple of problems. We want to get a by itself on the right-hand side. The easiest way to do that is to first get rid of the number here. A minus 13 can be canceled out by adding 13 to both sides of the equation. That cancels out the 13. We'll have just 6a left over. It's positive, so again, I don't have a negative sign to worry about. And we'll have 4 plus 13, which will be 17. And then, to get a by itself, to cancel out the 6, I'll divide by 6 on both sides. And so we end up with this not so nice answer, right? And that's going to happen more and more often the deeper you get into algebra. Is they're not going to hold back as much. So if you're used to having a lot of problems that always work out to give you nice answers, that's because the textbook's being kind of nice to you, or your teacher's being kind of nice, giving you problems that work out nice. That becomes less and less the case as you go further and further into this course and also into college algebra. So we end up with 17 on top over 6, which doesn't reduce, and we don't want to write it as a mixed number. Most times in algebra, you don't want mixed numbers. They're just more difficult to work with in algebra. They're nice for measuring things. So if you want to, for example, if I told you I ran 17/6 miles this morning, you probably wouldn't have a very good sense of how far that was on the surface of it. But if I said I ran 2.8 miles, that gives you a better idea of how far I ran. So that would be 2 5/6 of a mile, by the way. I'm sorry. As a mixed number, it'd be 2 5/6. Or if I said, here's a recipe, you need 17/6 cups of flour. Well, you wouldn't really know how much to measure. But if I said you need 2 5/6 cups of flour, you have a much better idea. So mixed numbers are good for measuring things. They're not so good for computations. And so in algebra, since we're doing a lot of computations, it's easier just to leave the fractions as an improper fraction. And that's usually the way Math Excel is going to want your answer. And so we'll just leave our answer like this: 17 over 6 equals A, right? That's our solution. Now, if you did this problem first before watching me do it on the video, and you went the other direction, if you subtract A to the left-hand side, then you might have got the answer as A equals negative 17, because that's what you would have got on the right-hand side, negative 17, divided by negative 6. And so if that's the answer you got, it's really the same answer. So you did it correctly, very good. But you don't want to leave your answer with a double negative. So if this is the answer that you come up with, you need, even though the fraction doesn't reduce, you don't want to leave it as a negative over another negative, right? A negative divided by a negative is positive. So make sure you cancel out those double negatives before you type in the answer to Math Excel. All right, let's take a look at the next example. All right, so this one looks pretty similar to the last couple of problems that we've done, but there's a twist here that you should run into pretty quickly, which is that we want to get y by itself on one side of the equation. So just like we did in the last couple of problems, we'll cancel out a y from one side. So let's say we want to cancel out this y from the right-hand side. We're adding 9y, so to cancel it out, I'm going to subtract 9y. If I subtract that from the right-hand side, I got to do the same thing to the left-hand side. I don't have a choice. So what are we left with when we do this? Well, just as we intended, on the right-hand side, the y's cancel out, and we have just a 23 left over. That's kind of what we've been dealing with this whole lesson, so we're kind of used to that by now. But something unusual that happens here is the same thing happens on the left-hand side, right? A lot of students sometimes don't see it, right? They'll think, oh, those cancel out, but here I have a y left over. No, you don't. You don't have a y left over here either, because 9y minus 9y, just like on the right-hand side, on the left-hand side, they cancel each other out this time. and we're left with a negative 4. And so your variable just completely disappears on you, which is a little bit unsettling because our whole focus is let's get this variable by itself on one side of the equation, and now it's just gone. It's not even in our equation anymore. So whenever that happens, if you're trying to solve an equation and your variable just disappears like it just did, then you have a special case. You have a special outcome that you have to be ready to address. And the way you address it is to see, well, what does it look like after the variable has disappeared? We have negative 4 is equal to 23. And without the variables there, we can now determine if this is a true statement or a false statement, right? So let me say that again because my voice kind of cut out. We can now determine if this is a true statement or a false statement. And this is false, right? Negative 4 does not equal 23. This is always false, which means the original equation is always false, right? So if your variable disappears, the thing that you get, again, is still equivalent to the original equation. So if 9y minus 4 equals 23 plus 9y, then it would also be true that negative 4 equals 23. But that obviously isn't true, which means the original equation isn't true. It's never true, right? It's always false. No matter what number you try to plug in for y, it will always be false. So what we want to address here are the solutions to this equation. What numbers make this equation true? Nothing. No numbers can make this equation true because this equation is always false no matter what. That tells me that this equation has no solutions. All right. And so you'll see on your homework that it'll give you a few options when you're answering these questions. One option is the answer is blank, and you type in your answer into the blank. Another option is there's no solution to this equation. That's what we would select in this case. It's not on the screen here, but it'll be on your homework. And then the third option is there are an infinite number of solutions, which we don't have in this case, but that'll be another option that you can choose on the homework. All right. So this is what it looks like when there's no solution. The variables disappear, and you get something that is false. All right. Let's take a look at this one. Very similar situation. Similar things about to happen. Right? We want to get rid of x from one side of the equation. We have to if we want to try to solve this equation. So let's cancel the x out from the right-hand side. I'll do that by subtracting 10x. That'll cancel that out. I got to do the same thing to the left-hand side. And what happens is the x's cancel out from the right-hand side, which is exactly as I intended. And I'll have negative 17 left over. But incidentally, not that I intended this, x cancels out from the left-hand side as well. It just happens. So what I have left over on the left-hand side is also a negative 17. So very similar outcome to the last problem, except this time, the result we get is true. This is always true, right? So we get negative 17 equals negative 17. That is always a true statement. If this is always true, that means my original equation is always true. Doesn't matter what number you were to plug in for x, it's always going to come out as a true statement, which means any number will be a solution to this equation, right? If a number makes it true, if a number makes your equation true, that means it's a solution to your equation. Any number makes this equation true, which means any number will be a solution. So if you get something that's true, right? So if your variables cancel out and you get something that's true, that means the solution set is all real numbers. So that's the answer you want to pick. It may not say it this way verbatim. It might say infinite solutions, or it might say negative infinity to infinity, but it'll be the third option, right? And so that's the option that you want to pick in this case. So the solution set is all real numbers. Any number is a solution here. We have an infinite number of solutions. Sorry, I kind of messed this up here. All right. Very good. Okay, so those are some special cases you got to be on the lookout for that are just going to kind of pop up randomly on the homework. So and that's how you handle them. And you know it's a special case if a variable disappears on you. Right? If your variable just disappears, it's either no solution or all real numbers are solutions. Right? It's complete opposites of each other. And the way you tell the difference is, does it come out true or does it come out false after your variable disappears? All right. So we have a couple more problems here. I think there's only a few more. This time we have a parenthesis, so that's kind of a new obstacle for us to deal with, and it has to be dealt with before you can start moving things from one side of the equation to the other. So I can't add or subtract or multiply or divide the same thing on both sides of this equation until the parentheses are out of the way, because otherwise it's going to become a mess. So to get rid of these parentheses, I'm going to take the 3 that's outside the parentheses and I'm going to distribute, use the distributive property, multiply it to both terms inside the parentheses. So I'll have 3 times x, which is 3x, plus 3 times 4, which is going to give me 12. The right-hand side doesn't change, it's unaffected by this. And now that the parentheses are out of the way, this problem is pretty similar to the problems that we were looking at earlier. I'm going to get x by itself on one side of the equation. A lot of students have the habit of always getting x on the left-hand side, but there are definitely situations where it's better to get x on the right-hand side, and this is one of those situations. So let's get rid of this x on the left-hand side by subtracting 3x, canceling it out. I'll do the same thing to the right-hand side. So here the 3x's cancel out. We'll have a 12 left over on the left-hand side equals 6x minus 3x, which is 3x. And now to isolate that x, to cancel out that 3 that we're multiplying by, we're going to divide by 3 on both sides. And we'll get that x is equal to 4. Excuse me, x is equal to 4. All right, so with parentheses, just get rid of the parentheses by distributing so that there's no need for those parentheses anymore. And then things could be moved around from the left-hand side to the right-hand side as needed. All right. This one we have a parentheses here. There's no number in front of the parentheses, so you got to be careful at how you look at this. Some students will take the 8y and distribute it into the parentheses, and that's not what's getting multiplied to the parentheses, right? So you want to look at what's just in front of the parentheses. If there's a, if I don't know how I want to say this, anything that's further away than that is not getting distributed into the parentheses. All right. So we're looking here just in front of the parentheses, and there's nothing there, which means it's an invisible 1. Right? So we have a 1 here, which has a minus sign in front of it, which means it's a negative 1. And that's what we're going to distribute into the parentheses. The 8y is not part of that. So the 8y is unaffected by this operation. We're just going to copy it down. We have 8y. Negative 1 times 5y will make this negative 5y. And then negative 1 times negative 15 makes this positive 15. And again, the 36 is unaffected by that operation, so we just copy that down. So we distribute the negative sign into the parentheses, and that allows us to get rid of the parentheses. Now, before we start moving things from one side to the other, and this is pretty common when you have parentheses to deal with, you want to tidy things up first. So before I start moving the y's or the 15 or whatever, let's simplify, combine things together that can be combined together before we start moving things from one side of the equation to the other. So we have these two like terms here, so let's combine those together. 8y minus 5y combined together to give me 3y. Right? 8 minus 5 is 3. The variable part stays the same. The plus 15 just gets copied down. The 36 gets copied down. And then to get y by itself, this is kind of becoming a broken record, right? We've come across this situation multiple times so far in this homework. We add or subtract the number first, so we'll subtract the 15 over to the other side. We get 3y is equal to, what is this going to be, 21? Right? And then to get rid of the 3 there, we'll divide by 3 on both sides. And I'll write the answer over here. We get y is equal to 7. All right. So that's how you deal with that parentheses, combine like terms, and then you're back in familiar territory. All right, let's take a look at, let's see, this is the last example, and I think it's the last problem that you're going to have on your homework if you're taking my class anyways. And it's a doozy of a problem, and it's going to be pretty easy to make mistakes because there's just a lot of things to be simplified here. Which means there's going to be a lot of steps that you have to take, and the more steps you have, the more likely you are to make a mistake. So just be very careful as you take each step. Pay attention to what you're doing. Be careful with the numbers, and to just take it one thing at a time, and write things down. So I find when I watch students work on their math, they seem to be hesitant to want to write on the paper, and so they try to do as much in their head as they can, or with as little writing as possible. And the best thing to do is not to try to do this with as little writing as possible, but to be as organized as possible. And to be organized, it really helps to keep writing the equation down repeatedly. Even if something isn't changing, just copy it down so that the equation stays intact. You see how it all still fits together, and you're doing good bookkeeping. You're keeping track of things and being organized. That's the best way to avoid making mistakes. All right. So this might take a little bit of time to get through. Let's go ahead and give this a try. So we want to get rid of all these parentheses. These brackets are also parentheses. They just use a different symbol so that the parentheses don't all blend together. But treat them just like you would treat parentheses. And this one's a little bit tricky because we have parentheses inside of parentheses, right? We have the 4 minus z in parentheses. That's inside of this parentheses here, these brackets. So the best thing to do is to work your way from the inside out. Start with the innermost parentheses, get rid of those first, simplify, then deal with the outer set of parentheses, get rid of those, simplify, until all the parentheses are gone, and then you can start moving things, and then once you've simplified, you can start moving things from one side of the equation to the other. So don't even worry about trying to get this 26 over here yet, or this 5 over here. Let's get rid of the parentheses first, simplify, and see what we're working with, and then we'll go from there. So the first thing I want to get rid of is the innermost parentheses here, which is this one right here, right? And so to get rid of this parentheses, I have to distribute the 3 into that parentheses. But the minus sign has to go with it, right? So whatever sign's in front of that number is part of that number and has to get distributed with that number. And so we have negative 3 times 4, which will be negative 12. And negative 3 times negative z, which is positive 3z. All right. Now, nothing else changed on the left-hand side, but I'm going to copy it down anyways because I want to be organized about the way I'm doing this, and I want to see how it all fits together. So the 5 is going to get copied down. The brackets will get copied down. The 3 in front of the brackets gets copied down. And then this minus 5 that's tacked on to the end, which is easy to forget or to overlook, we need to copy that down as well. All right, so that's the left-hand side, first step on the left-hand side. Let's take a first step on the right-hand side, same idea. The innermost parentheses here, I'm sorry, I'm not able to write a straight line. We're going to distribute the 3 that's in front of that parentheses into that parentheses, and only into that parentheses. This 3 doesn't get multiplied to this 2 over here, right? It's not part of that parentheses, just these two terms. So 3 times 5z will be, I'll write a little bit further over here, will be 15z, and 3 times negative 4 will be negative 12. Right? We'll still, and everything else gets copied down, right? So the plus 2 gets copied down. The brackets around this whole thing are going to get copied down. The 5 in front of the brackets gets copied down, and the minus 26 gets copied down. Right? Those were unaffected by that operation, but we still want to write them on the second line so that we can see how the equation's all fitting together. All right, now simplify. Before you distribute this 3, let's just simplify this first. So before you take that next step, tidy things up a little bit, right? Combine like terms. We have 5 minus 12, which is negative 7, and then the plus 3z gets copied down. Still in brackets, still copy the 3, still copy down the minus 5. Same thing here, combine these like terms. Negative 12 plus 2 is negative 10. The 15z gets copied down. Brackets around that still. Here's the 5, here's the minus 26, right? So things are looking better, right? They're not nearly as complex as they were to begin with. Now we're ready to get rid of the second set of parentheses, these brackets here, by, again, distributing. So we'll distribute the 3 into this brackets here. We'll get 3 times negative 7, which is negative 21. 3 times 3z is 9z. And I don't need to write the brackets anymore because since I distributed, I don't need the parentheses or the brackets anymore. And I'll copy down the minus 5. So again, don't forget about that term. It's still sitting there. We haven't done anything with it yet. Same thing here. We'll distribute. We'll have 5. Sorry, the arrow didn't quite get where it was supposed to. 5 times 15 is 75. Z minus 5 times 10 will be 50. And then we'll have the minus 26 that gets copied down. Sorry, I keep pressing this button on the pen. It keeps erasing what I'm writing. All right. And so we have this. And now all the parentheses are out of the way. But don't start moving things from one side of the equation to the other just yet. because we want to simplify first. And so we'll have combine like terms. Now, careful about this. A lot of students will say, oh, this plus 5, I want to combine it over here with the 21. I have to add the 5 over to the 21. You don't have to do that because they're already on the same side of the equation, right? The equal sign is right here. You don't have to move the negative 5 over. It is already over there. It's already over there with the 21. You just combine the two together. So we have negative 21 minus 5, which will be negative 26, plus 9z, right? Just copy that down because it didn't get affected, equals 75z minus 76, right? Because we're going to combine these two together. Negative 50 minus 26. Again, I don't have to add the 50 over to the 26. They're already both on the same side of the equation. I just combine them together as they are. So now the numbers are a little bit crazy, but this is pretty familiar territory, right? We've done this kind of problem already a few times. Let's get z by itself on one side of the equation. Now I'm ready to move things from one side of the equation to the other. I want to get z, I want to go to the right-hand side again because I like to keep the numbers positive as much as I possibly can. So I'm going to subtract 9z to the right-hand side. Right? And so the 9z's here are going to cancel out. I'm going to continue up this way. We'll have the negative 26 left over on the left-hand side equals, right, the 9z's cancel out. We'll have 75 minus 9z, which will be 66z minus 76. So I believe that's correct. All right, and then we want to get z by itself, so I'm going to add the 76 over. Yeah, because if I was subtracting 10 to be 65, so 1 less would be 66. I'm pretty sure that's right. All right, plus 76, right? Add that over. I'm sorry, this thing's, I don't know if I've been going for too long or this file's gotten a little too big, but it's starting to get a little laggy here, so let's try that again. I'll go a little bit slower. Add 76 to both sides. Equals 66z. All right, whoops, what am I doing? Okay, I'm making mistakes at the end here, unfortunately, sorry. Let's get rid of the equal sign there. Let's do it the way we've been doing it the whole time in this video. All right, the 76's are going to cancel out. We will get 50 over here, right? So if you add these together, you get positive 50 equals 66z. And I'm almost done, but I need a couple more steps, so let me continue up here in the corner. Right here. Right, and so we'll have 50 equals 66z. Sorry, it's getting laggy here. All right, and so we want to get z by itself by dividing 66 from both sides. All right, and we're going to get kind of this not very pleasant answer. Let's try that again, 66. All right, and we have to reduce it this time. So we get a fraction that has to be reduced. I'm really sorry about this. It was working so good up until this last problem. So we get 50 over 66 equals z. All right, and if you type that in the Math Excel, it's going to tell you you have the right answer, but it's not in the proper form. It's not simplified. So we have the correct answer, but it needs to be reduced. And so I think we can reduce it by dividing a 2 out of both of these. I think that's all we can do. So we'll divide a 2 to reduce this fraction. I'll try to make that a 2. And we'll divide a 2 from the denominator. And so we'll get 25 on top. Let's try that again one more time. 25. And on the bottom we'll get 33. Okay. Let's try that one more time. Okay. And so we get z equals, not the greatest answer, we get 25 over 33. All right, so that concludes section 1.1. So you should go ahead and give the homework a try. You should see a lot of these problems on your homework, except the numbers will be a little bit different, but the problems will be pretty similar. And if you have any questions or anything, please, if I'm your instructor, contact me and let me know if you have any questions about any of these problems.